Solar physicists are not talking about the CME heading toward Earth right now. They are talking about what is still on the sun's surface, rotating slowly, silently, directly into position. And the language they are using behind closed doors is language they typically reserve for historically significant events. 4 seconds of silence in mission control after astronauts described the moon as the wrong color told us something about the gap between instruments and human perception. What is happening on the sun right now is telling us something similar. Except the stakes are not a training simulation. They are civilization-level infrastructure. The sun rotates approximately once every 27 days as seen from Earth. That means sunspot regions currently sitting on the eastern limb, partially hidden, partially unmeasured, will rotate to directly face Earth within days to weeks. Not months, not years. Days to weeks. And what is rotating into position right now has solar physicists using words they do not use lightly. The CME currently heading toward Earth is real. It is measurable. It is the thing every news platform is tracking with colored maps and impact probability windows. But the physicists most familiar with solar behavior are not watching the CME. They are watching what comes next. And those are not the same thing. To understand why, you need to understand what solar maximum actually means. The sun runs on an 11-year activity cycle, swinging between periods of relative quiet and periods of intense, sustained magnetic violence. Solar maximum is the peak of that cycle. It is when sunspot activity is highest, when magnetic field lines are most compressed and tangled, when the probability of significant events is not elevated by a small margin. It is elevated by an order of magnitude. Solar maximum is underway right now. This is not a projection. This is not a forecast range. Solar physicists confirmed it. We are inside the peak window of the most active phase of the sun's 11-year cycle, and the specific configuration of what is currently on the solar disk is what separates this moment from routine solar maximum activity. Here is what that configuration looks like. Multiple active regions are distributed across the solar disk simultaneously. Not one, not two. Multiple, positioned at different latitudes, carrying independent magnetic flux systems, each capable of producing significant flare events on their own. When those regions are positioned to interact, the calculation changes entirely. The sunspot region responsible for the current X-class flares is not an isolated phenomenon. It is part of a broader loaded configuration. Loaded is a word physicists use deliberately. It means stored energy. It means magnetic field lines that have been twisted, compressed, and built up over days and weeks, accumulating potential that has not yet been released. Loaded does not mean passive. It means ready. The sun's eastern limb is where this matters most right now. Regions on the eastern limb are rotating toward Earth-facing position. The geometry of that rotation is not incidental. It determines whether a flare or CME launched from that region sends its energy toward Earth or away from it. Right now, the geometry is rotating in the direction that matters. X-class flares are the most powerful category in the classification system. They are not uncommon during solar maximum, but their consequences depend almost entirely on where they originate and which direction the sun is facing Earth at the moment of release. An X-class flare on the limb misses. An X-class flare from an Earth-facing region does not. The difference between those two outcomes is the rotation of a star 93 million miles away. In September 1859, a solar event hit Earth that rewrote the baseline for what this planet can absorb from its own star. Telegraph operators reported sparks jumping from their equipment. The northern lights were visible in Cuba and Colombia. The entire global telegraph network failed simultaneously. That event is called the Carrington event. It is the reference point that every solar physicist uses when describing worst-case scenarios, and it is the event they quietly reference when the current configuration comes up. The Carrington event did not happen during a routine week of elevated solar activity. It happened because of a specific configuration. 2 sunspot groups in close proximity with a second major CME launching into the wake of a first, traveling faster because the first had already cleared the path. A double punch. The first impact compressed Earth's magnetic field. The second hit the compressed field with full force. The combination produced effects neither event would have produced alone. Solar physicists have a name for that sequence. They call it a CME cannibalism event. A faster CME overtakes a slower one in transit, merges with it, and arrives at Earth with combined energy and magnetic field geometry that neither carried individually. The current configuration has the structural prerequisites for that kind of sequence. Multiple active regions, successive eruptions, rotation bringing new regions into Earth-facing geometry over days. There's no planet-killing scenario being discussed here. Earth's magnetic field is not going to fail. The atmosphere is not going to disappear. The concern is not extinction level. The concern is infrastructure. And the infrastructure concern is specific enough to be named, modeled, and studied by agencies that do not typically discuss their work in public. High-voltage transformers are the load-bearing walls of modern electrical grids. They are large, expensive, custom-built, and not sitting in warehouses waiting to be swapped out. The lead time on a replacement transformer is 12 to 18 months under normal manufacturing conditions. A severe geomagnetic storm does not damage one transformer. It can induce geomagnetically induced currents across entire grid sections simultaneously, stressing multiple transformers in multiple regions at the same moment. A 2008 National Academy of Sciences report on severe space weather estimated that a Carrington-level event would put over 130 million Americans at risk of extended power outages, not hours, not days, weeks to months, depending on the speed and scale of transformer replacement. That report was not written as a worst-case exercise. It was written as a planning baseline. Satellites are not insulated from this. A severe solar event compresses the magnetosphere on the sunward side and stretches it on the night side. That compression pushes the Van Allen radiation belts to lower altitudes. Satellites in low Earth orbit that were safely above the primary radiation environment suddenly find themselves inside it. Spacecraft charging, single event upsets, accelerated component degradation, GPS, communications, weather observation, financial transaction processing. The things that run on space-based infrastructure are not optional systems. The irony of this moment is the same irony that defined the Artemis II story. We have more data about the sun than about any other star in the observable universe. We have continuous solar observation from SOHO, from SDO, from stereo, from ground-based observatories that have been running uninterrupted for decades. We have magnetograms, coronagraphs, extreme ultraviolet imaging, radio burst detection. We have built an extraordinary sensor network pointed at a single star 93 million miles away. And we still cannot predict with certainty whether a specific active region will produce a major flare in the next 72 hours. We can identify probability ranges. We can characterize magnetic complexity. We can flag configurations that have historically preceded significant events. We cannot tell you the event will happen, or when, or exactly how large. The gap between our instrumentation and our predictive capability is real, and it is not shrinking as fast as the infrastructure, depending on that prediction, is growing. The current solar maximum was expected. The cycle was tracked, modeled, and forecast years in advance. What was not fully anticipated was the intensity. Early forecasts predicted a moderate solar maximum, below the peak of the previous cycle. Those forecasts were revised, then revised again. The current cycle has exceeded the initial predictions, and the active regions now rotating into Earth-facing geometry are products of a maximum that has run hotter than the models expected. That gap between model and reality is familiar. It is the same gap that appeared when the Artemis II crew looked out the window and saw a moon that did not match their training imagery. The instruments said one thing. The direct observation said another. The assumption that the model was adequate turned out to be the problem, not the measurement. What solar physicists are watching right now is a configuration, not a single event, not an isolated flare. A configuration of multiple active regions, a rotating disk bringing new geometry into Earth-facing position day by day, a solar maximum running above forecast, and a sequence of eruptions that has already produced X-class events. The question they cannot answer yet is whether what has already happened is the event or the opening. The CME currently heading toward Earth is measurable. It has a projected arrival window. Its magnetic field orientation can be estimated but not confirmed until it reaches the L1 monitoring point, roughly 1 million miles from Earth, which gives operators approximately 15 to 60 minutes of warning, depending on solar wind speed. That window is the entirety of the operational margin between detection and impact for any Earth-directed event. 15 to 60 minutes, that is the full warning timeline. Not days, not hours. Minutes at the outer limit. The decision to take satellites into safe mode, to reduce load on transformer-heavy grid segments, to alert operators of high-voltage infrastructure, all of it has to happen inside that window. And the window is only available at all because a monitoring satellite is parked at L1 doing nothing but watching. If that satellite were not there, the warning would not exist. NOAA's Space Weather Prediction Center issued enhanced watches during this period. That is the official structure that turns solar observation into actionable warning. But watches are probabilistic. They describe risk windows, not specific events. They tell operators that conditions are elevated without telling them whether a major impact will occur in the next hour or not occur at all. Operating inside that uncertainty is the full reality of space weather response. There is something else sitting behind this story that does not fit neatly into a forecast model. The sun is not just active in one region right now. The configuration that has solar physicists using careful language is the distribution. Multiple loaded active regions across the solar disk is not the same as one powerful region doing all the work. It means the solar disk itself is in a state of elevated simultaneous potential, not a single loaded gun. Several, pointed in different directions, with one or more rotating toward the only direction that matters. Apollo astronauts described a moon that looked wrong from the moment they saw it, close enough to see clearly. Every mission that put humans on the surface recorded visual discrepancies, between the training imagery and the actual environment. Those discrepancies were filed and not acted on for 52 years, because there was no mission that needed to act on them. The solar configuration being discussed right now by physicists, who are not talking to press conferences, has been sitting in the observation record for weeks. The difference is that space weather does not wait 52 years to force a response. The rotation does not stop because the warning system needs more time. The active regions do not hold their stored energy until infrastructure operators are ready. The sun is on its own schedule, running its own cycle, executing its own geometry, and the window between identification and impact has always been measured in minutes. This is not the story of a disaster that has happened. It is the story of a configuration that exists right now, that is measurable, that is being tracked, and that has the structural characteristics of the kind of event that fills the history books, not because it was unprecedented, but because it was the moment the gap between what we knew and what we had prepared for became impossible to ignore. The Carrington event was not predicted. Neither was the 1989 Quebec blackout that left 6 million people without power for 9 hours after a geomagnetic storm took down the Hydro-Quebec grid in 90 seconds. Neither was the Halloween storm of 2003 that damaged more than a dozen satellites, forced transpolar flights to reroute, and produced a radiation environment that exceeded the design tolerances of instruments trying to measure it. The instruments went off scale. The event was larger than the sensor designed to record it. The sun looked wrong to solar physicists before each of those events, too. Not wrong in a way that anyone was publicizing, wrong in the way that a configuration looks when it has exceeded the typical parameters and the models are running at the edge of their validated range. Wrong in the way that trained observers recognize without being able to fully articulate why. The Artemis II crew recognized that feeling when they saw the moon. Physicists are recognizing it now. The loaded configuration on the solar disk is real. The rotation bringing it into Earth-facing geometry is real. The solar maximum context that makes the existing active regions more consequential than they would be at solar minimum is real. The 15 to 60-minute warning window is real. The infrastructure exposure modeled in official government reports for over a decade is real. None of this is theoretical. None of it is speculation. It is the documented current state of a system that does not wait for the story to catch up to it. The CME heading toward Earth may not be the main event. It may be the preview. That sentence is not alarmism. It is the operational framing that solar physicists use when a configuration has more stored energy than the first release, when the geometry is still rotating, when the solar maximum conditions mean that what is fired is not necessarily what is finished firing. Preview is the professional language for a system that is still loaded. We are living in a moment where the James Webb Space Telescope is identifying molecular signatures in the atmospheres of planets orbiting stars 1,200 light years away, where AI can generate photorealistic imagery of places that have never existed, where autonomous systems make decisions faster than any human operator can verify them. And the closest star to Earth, the one that powers every biological and technological system on this planet, can produce an event that outpaces our warning infrastructure by a margin measured in minutes. The sun looked wrong, not in the theatrical sense of something that cannot be explained, in the precise scientific sense of a configuration that exceeds the typical parameters, that has physicists pulling historical comparison data, that is generating the kind of careful, specific, loaded language that people who measure things for a living use when the measurements are telling them something they would rather not have to say out loud. The window's open. The rotation is running. The stored energy is real. And we still do not fully know whether what has already happened is the whole story, or whether the geometry still rotating into position is carrying the part of the story that hasn't been written yet. The math does not wait. The sun does not pause for press conferences. The clock is running, and the configuration is still there.